My project was to restore the dehydrator at ISK. The dehydrator at ISK was not being used, so because it wasn't effective enough at dehydrating, and there was a demand for it, like the Greenhouse Club and Design and Engineering needed it to dehydrate their vegetables, some seed balls they were doing for experiments. So they needed the dehydrator to actually work so that they could complete their projects. So I came up with the idea of restoring the dehydrator as well as making it all weather, because in Nairobi and of course all around the world the weather is not always sunshine and rainbows. So I would be able to do this by attaching a secondary heat source, and I would have used the biogas system I created earlier, and I would use the biogas and connect it to a stove, and that stove would be generating heat, um, and a heat plate would sit on top of it. And then this was for my first idea. I would have a thermoelectric generator, also known as a TEG, attached to the side of the system. It would have the hot end on one side and the end on the other side, and this temperature differential would create electricity so that a fan could run the heat through the dehydrator. And it would be a secondary, it would be outside the dehydrator, so that it wouldn't burn anything because the dehydrator was made out of wood. So, first of all, the problem was we didn't have a tag. We needed a lot of material to actually create the system outside of the dehydrator, and we didn't have a heat plate. So we realized that when we were creating it, it would be really big. So we decided, my supervisor, Mr. Sudra, helped me with a tag that he already had, and this was BioLite. So it works the same way that my concept did, where I had the tag and I had the heat source. So the best thing about the BioLite is that it actually had a charger in it. So it had a battery, and you could use that to create electricity. And you didn't have to do all the wiring and all the setup yourself. It was already there. So this saved a lot of time, and it's overall more efficient than my idea. So this would have helped a lot. But originally I thought if I could just use the back of the camp stove, BioLite camp stove, because it came with a system that allowed you to burn fuel to generate electricity. If I used that for the dehydrator, it wouldn't have worked. So we came up with the idea to include the tag into the dehydrator and not outside as an external component, and you'd keep the stove as well as the heat plate inside as well, and this way the less heat would be lost, would save on materials, and it would be way more efficient. So the materials we needed were the tag which we got, the heat plate, which needed to be out of highly conductive material, and we needed a fan to run the heat through it. So we decided to use aluminium. This aluminium would be highly conductive, so then less heat would be lost, it would be more efficient. I had to use a PWM fan, which the school had, and cut it to connect it to a USB, because originally it had a mole connector. Then I had to design sleeves for the hot end of the TEG, and then from there I added everything together. I put stands, and it looks like this. So this is attached from the outside. The TEG needed to be on the outside so that the heat differential would work. And then the USB is connected to the fan over here. And then you have the sleeve with the aluminium and the hot end connected, and then the heat plate. So this would allow for the heat to be generated inside the system, and then the fan would allow for convection, for faster convection, and overall it would make the dehydrator more effective.